Alright guys, sorry I couldn't be with you this morning, but you get me virtually, which is kind of cool. I want to talk a little bit about our lab report that we have coming up, and specifically how you present data in a scientific paper. I know for last night's homework you put all of our data that we collected on our tree plot into a Google Sheet. And I want to talk a little bit about how that data should be formatted so that you can eventually turn it into graphs and other figures that'll help you best communicate to your reader what you found. So this document here is actually going to be your homework. I'm going to have you read this through and sort of get a sense of what we'll be doing for our lab report, but I want to point you to a specific section here, the results section of your lab report, right? This is where you're going to present your data. And you have a couple options as to how you present your data. You can either present it as tables, right, or graphs. Generally, right, when you are trying to find a relationship between two variables, graphical data is going to be the most sleek in terms of communicating the relationship between your two variables, right? Your y variable and your x variable, y being dependent and x being what you manipulate. And being able to build graphs and communicate your data clearly to a reader is really important. So hopefully if you want to pull out your computers and open up your tree rating spreadsheet and follow along with me, I'm going to walk you through some formatting that's going to be really helpful here. So hopefully you've gotten maybe this far in your data sheet, right? This is sort of like what you hopefully had in your lab notebook. Right, we've got tree number here, the type of tree, and then hopefully your tree rating, well, misspelled here. Instead of tree rating 1, 2, and 3, you're going to have dates up here, right? This is actually a classmate of yours data that I've taken, and they did not record the dates for 1, 2, and 3, right? But these should be, hopefully, you have a date 1, right, date 2, and date 3. If you don't have those, find a classmate that was a bit more diligent about taking notes and get those dates because you will need them to write a comprehensive lab report. So, this is great. It's got all the data we need, right? It has everything we collected. But it's really hard to discern patterns, right, just by looking at these numbers. We've got to do a lot of sort of mental gymnastics when we look at this to try to figure out any sort of pattern among the tree types and even sort of along the dates. I mean, we can kind of see that, as the data points progress, they get lower and lower. But again, it should be, when you present something in your report, you're going to want it to be sort of, someone glances at it and they automatically see what you're trying to communicate. And that isn't necessarily happening here. So the first step here in terms of making this data a little more palatable is going to be to organize it in a way that'll help us analyze it. And one way that I would suggest organizing it would be by tree type. So, clustering all of the red oaks together, all of the red maples, right, so that you can easily visualize them. And, you can do this a couple different ways, but the way that I decided to do this was to put the dates, so that would be date 1, this is going to be date 2, right, these are going to be vertical, and then to put our tree numbers along the top here. And I would recommend that you actually do that, put your tree number up along the top, because when we get to graphing, the way that the program is going to look is it's going to look for your manipulated variable here on the left, and it's going to look for your responding variable up here on top, right? So we're going to want sort of our responding variables to be our phenology ratings, right? Which are denoted by our tree numbers. So what I've done here is I've kind of grouped all of the American beaches together. and I made a column for the average, and I'll show you how to take the average in a second. But an easy way to do this, right? So, maybe this is your first sheet. You can click this little plus here to add a sheet, right? And you get a new sheet, and that's how I got this sheet number 2. And you can actually just copy paste, right? So I've already done all my American beaches. I'm just going to go in alphabetical order, and I'm going to go ahead and do all my red maples. So I'm going to copy, paste all of the tree numbers in there, right? This is going to be a little tedious. So we're going to spend, some time in class today going through and reformatting our sheets. If you're a Sheets genius and you've already done all this, I think you're probably going to have some classmates who may need your help. So it's good that we have experts among us, right? So I've gone ahead and these are all my red maples, and I'm going to just color code them so that I know that they're red maples. I'm not going to write that. If you go up to this little fill color box, you can pick, I'm going to make them orange. I'm going to go down here to my key, that orange color. These are red maples, right? And that, it makes my data pretty, and it also gives me a good sense of what's actually going on. So then I need to go ahead and fill in my data. So let's see, my first red maple was a 200. Go ahead and fill those down. 200. Double check that number. And then because I'm wonky, I did this one next, which was a 0.5 and then a 00. And then I did 5350 right here, 1.5 and then 2 zeros. And finally 538, that was right here, that was 100. Cool, so now I have all of my data in a way that is sort of readable here. And what's interesting about this, right, the way that I've set this up is it lends itself really nicely to creating a graph. And if creating a graph isn't something that you've done before, I'm going to walk you through it in a second. But what I would like you to do right now is go ahead and set up the rest of your data like this. I'm not going to do it, but I want you to go ahead and fill in American Beach, and then next will be Red Oak and then White Oak, right? So you have all of your data set up in this way. And if you would just go ahead and pause the video, because I'm going to pick back up, but pause the video, go ahead and set up your data sheet, and then I'll show you some other cool things that you can do with sheets here. Alright, so hopefully you have your data formatted by this point. I'm going to go ahead and show you how to take an average here, right? So say I wanted to find the average for all American beaches on the first date. I can go ahead and click this cell, right? And I'm going to go equals and start typing the word average, right? And they give me a bunch of different options here. I'm going to click average, right? And then I highlight the cells I want to take the average of, right? There you go. My average reading for the American beaches on this date was about a 2.6, right? And if I want to apply this mathematical function to the rest of these, I can just click, right, if you go over to the corner of this cell, you're going to get these crosshairs here that are thin lines, and you click and drag down, and when I release, right, it's going to give me the average for the other dates, right? So it's applied this function to these other cells, which is kind of cool, right? It's taking the average of B3, which is right here, through E3, right? So sort of pulled it down, which is really cool. That can be a handy tool as you move forward. So I want to talk a little bit about graphing. You're not going to generate graphs for your report yet, but this can be a little tricky for some people in terms of formatting, so I want to walk through it. The first step in creating a graph, is to highlight your data, and this can be kind of tricky. You have to figure out what data you want to highlight. So for my graph, I think I'm going to look at just the American beaches, and I want to look at the date. So my graph, I'm hoping, will show the relationship between the date and the phenology reading for these American beaches. So I'm going to go ahead and highlight all of these cells, right, date and the American beaches, and I'm going to go to Insert, Chart. Oh, and I get this weird bar graph thing. So Sheets is a pretty smart program, right? It thinks it knows best. So it's going to try to tell you what kind of graph you want to see, right? It's going to try to say, like, oh, you want a bar graph. But you have to be smarter than Sheets. You don't actually want a bar graph. In order to show relationships between different variables, the thing you want is this scatter plot. So to get here, I just went to Chart Type, drag down arrow, scatter, right? That looks better, right? So what this is showing me, right, and I have to do a little finagling and see what numbers match up, right? This is date 1, date 2, and date 3, right? And it's showing me here, right, the phenology ratings are on this side of the axis, right? So that's good. I wanted my responding variable over here, which it is, and my manipulated variable being the date down on my x-axis, so that's awesome. So this and each of these series, which are nicely color-coded, is each of my American beaches, right, showing the trend at which their phenology ratings changed. So one thing that you're probably going to want to do always on these charts is they're going to give you some sort of title and, you know, some axis label, and you're probably going to want to beef it up a little bit. So if you go to Customize, right, Chart and Axis Titles, you can assign a vertical axis title, right, which in our cases is Phenology Rating. And you can do a horizontal axis title, which is the date. And you can give it a nice descriptive chart title, which for us is going to be Phenology Ratings of American Beaches over the month of October, right? Sounds wordy, but this is exactly what this is showing, right? So better to say it and tell people what they're looking at right off the bat, right? And how much easier is this to look at and tell what's going on than this sort of conglomeration of numbers that we started with, right? Even just, you know, this graph versus, right, this whole mess, right? So that's what we're going for, is we want charts to be sort of like, ah, yes, I get it. Another thing that, you know, you might consider adding to a chart, if you go to series, you can add something called a trend line, which is sort of, you know, and most of the time with most of the data that we'll be dealing with, linear trend lines are going to be good, but they show you the overall trend of the data, right? So this is sort of showing us that as time goes on, the phenology ratings are getting less and less. So that's going to be important. Now, what you should be thinking about as you format your data is what you want to compare your ratings to, right? Because comparing them to the date is kind of, it's a little lame, right? As time goes on, the leaves will fall off the trees, duh. But we want to figure out why. Why is that happening? So some things that you could consider for your x-axis would be things like amount of daylight, temperature, amount of precipitation, right? Things like that could go in this column, and you could find the relationship between that. And we have a pretty cool website. It's called Weather Underground, where you can find the a variety of weather measurements on a given date in Plymouth, New Hampshire. Right, so if I wanted to know something about, say we went out on October 21st, right, I go ahead and plug that into Weather Underground, and I know the mean temperature, I know the amount of precipitation, I know the maximum wind speed, I can find the length of day, right? So these are all things that you can look up on Weather Underground and compare, right, to find, you know, what might be affecting our phenology data, right? So keep that in mind as you do your homework, right, which is going to be to read this and think about, okay, you know, I need to develop a hypothesis to write this lab report, right? I mean, you need to develop a hypothesis because you're curious, but in a utilitarian sense, you need to develop one to write the lab report. What might you be interested in exploring through phenology, right? And just a note as you read this paper, it says Casey 2011. This is Mr. Casey's rubric from 2011, and shockingly, it has not changed all that much, and I use the same one. So if you're curious, this is how I'm going to be grading the lab report. All right. So Sheets is, I learned how to do a lot of this graphing stuff on Excel. So Sheets is kind of new to me. I'm always learning new things. So you may be a Sheets expert and you might teach me something cool. So I always look forward to that. But this should be sort of a fun way to get into some data representation. All right. So if you still need a few minutes to sort of play around with making charts and sort of things like that, why don't you pause the video and take about 10 minutes to, finish up formatting your data and maybe try to make one chart of something, right? Maybe it doesn't work out quite how you wanted. It's not the final thing, but I just want you to play around with, maybe taking a few averages and creating a chart. All right, so spend about 10 minutes, talk to each other, right? See what's working, what's not working. Another great resource for Google Sheets is actually Google, right? So if you have a question about how to do something with Google Sheets, plug it into Google. There's, probably a million people out there who've had the same question and they've probably answered it at some point. So pause this video, give that a shot, and then we'll pick this back up. All right, let's see here. So switching gears a little bit, back to our discussion of primary succession. The next week and a half is going to look a little bit, we're going to do some stuff on succession and wrapping up ecology while we're writing our lab report. So we'll sort of jump back and forth between that stuff. But I wanted to wrap up our discussion of succession with this really nice infographic that's actually from Encyclopedia Britannica that I think really helps delineate the difference between primary succession and secondary succession, right? So primary succession is when succession starts from bare rock, right? There's no previous ecosystem that's left an imprint on the area, right? So it's sort of bare bones, starting off. And you can see, right, the pioneer species, right, are these sort of grasses and lichens, right? Remember, lichen is two organisms in a symbiotic relationship. We talked about that. Pretty cool. And they can live on this rock, right, because of that symbiotic relationship. And sort of as we ended class with a prompt last time, right, what determines, what species are going to grow during what stage in succession is really resources that are available, right? So during these intermediate stages of succession, plants that are, don't like shade, they like a lot of sunshine, they can maybe do well in soil that isn't quite so nutrient rich, isn't quite so developed, are going to do really well, right? So things that like sunlight are probably going to grow first, right? And then as these things that like sunlight grow, and create sort of a shady, more nutrient-rich environment, these other species that do well in shade environments are going to fill in and create our climax community, right? So in our stand of trees, we have a lot of oak, right, that we were out looking at, white oaks, red oaks. Those are a climax species, right? So that's indicative of the fact that our forest out on the trails hasn't had a major disturbance in a while, right? So important to note here with primary succession, right, this timeline's happening over hundreds of years, right? It takes a really long time for this colonization of bare rock to turn into a forest, and part of that is that this rock has to be degraded into soil over time, right? That's going to take a lot of time. Secondary succession, while it sort of appears to be following the same trajectory, right? The pioneer species move in, then intermediate species and climax species. It happens a lot faster, right? because we're building off of already created soil, right? The rocks don't need to be degraded down, right? We've already got soil in there. And, as a result, this can happen over a course of, hundreds, less than hundreds of years, or, it says 150 plus years here. So this is going to be a faster process, but it's also going to have some of the marks, perhaps, of the community that was there before, right? So it isn't necessarily starting from a blank slate. So what I'd like to do to sort of wrap up this succession study is there is a worksheet that's sort of a fun cut and paste where you have to match different succession patterns to their order. One of them is for pond succession, and you might be like, whoa, wait, we haven't done pond succession yet. We actually have, right? So the whole study of oligotrophic to mesotrophic to eutrophic, right, that progression of pond aging is actually pond succession, right? So we have seen succession before in aquatic ecosystems, and now we're just looking at it in terms of terrestrial landscapes. So that worksheet should be pretty straightforward. You sort of cut and paste out the different things. I think it'll make more sense when you have it in your hands, but I would like you to go ahead and work on that for the rest of the block.